Hello again. Today we're covering 1.1, which is lines. That means we've officially finished chapter R, the review section, but we are still reviewing. We're still just doing some algebra stuff that you should know coming into a calculus course. So 1.1, which is lines. Lines are, as you'll see, incredibly important in calculus. They sort of underlie everything that's going on. In particular, we'll talk about tangent lines to curves a whole bunch. So you will see where the lines actually come in this course, which means you have to understand how to work with lines. And before we talk about lines in general, just two quick sort of special cases, which are horizontal lines and vertical lines. All right, so here I've indicated a horizontal line. Here's the origin, x-axis, y-axis, and we've got this horizontal line with slope equals 0, right? It's not going up or going down, it's just a straight horizontal line cutting through the y-axis at this point 0k, so k units above the x-axis. And for horizontal lines, they have very simple equations, just given by y equals k, right? Where k indicates sort of how far above the x-axis it lives, or negative y equals negative k would be k units below the x-axis. And over here we've got vertical lines. So these are lines like this, right? Straight up and down, where the slope is, really it's undefined, right? We don't define the slope of this, but if you want, you could think of the slope as being infinite, right? It increases in value infinitely quickly, right? The rise over the run is infinite. And here we've got a vertical line cutting through the point k0, right? So this is k units to the right of the y-axis. Oops. I don't know why I labeled them this way. There's the y-axis, there's the x-axis. And vertical lines are just given by this equation, x equals k, right? You indicate the x value where it cuts through the x-axis. So vertical lines, infinite slope, or slope is undefined, given by the simple equation x equals k. Okay, so here's the general case of a line, right? This is just an arbitrary line that I've drawn on here. Again, x-axis, y-axis, here's my line. Not the straightest line I've ever drawn, but that's okay. And I've indicated a couple of important points. When you're looking at lines, you tend to want to consider the y-intercept, so that's where it cuts through the y-axis, this point right here. And sometimes the x-intercept where it cuts through the x-axis, which in this case would be this point right here. And I've also labeled two other arbitrary points, right? Two other arbitrary points on this line. I don't know the coordinates, so I've just called the coordinates of this point x1 and y1, and the coordinates of this point x2 and y2. So perhaps the most important thing to know about lines is the slope of the line, right? And looking at this, we can see, okay, well, it's definitely a positive slope, right? As you move from left to right, you're sloping upward, so it's positive slope. But how can I measure the actual slope? So we want the slope of this line. It's almost universally, as people talk about lines, or in the context of lines, people use the letter m for slope. So we'll use that here. And what is the slope? Well, it's the amount you go up, right? So it's the change in the y values divided by the amount that you go across, right? If you go up 10 units and across 2 units, well, your slope is 5, right? It's 10 over 2. So the slope is the change in y over the change in x. I think I said this when we were talking about vertical lines, but it's usually hear this called rise over run, right? It's the amount you rise. Sometimes you might have negative rise if you're sloping down, but it's the rise over the run, the amount you rise over the amount that you travel across. So it's change in y over change in x. And mathematicians are notoriously lazy, so this just became delta x, delta y over delta x, where this Greek letter capital delta is pretty much, again, in mathematics, universally represents some sort of change, some sort of differential. So it's the change in y over the change in x. And in this picture, I can actually measure this, right? Think about the difference between these 2 points. what's the change in y? How far above this point is this point? Well, it would be this height right here, right? It's a change in y. So it's the top point, y2 minus y1, over, how much did we change? Well, it's this distance here, so x2 minus x1. And it actually doesn't matter which order you write these. I could have done y1 minus y2 divided by x1 minus x2. It's totally fine, as long as you're consistent in always using the coordinates of one point first, right, y2 and x2, or the other way around, right? If I had y1 minus y2 over x1 minus x2, it's actually the same thing. I've just I've factored out a minus 1 from the top and the bottom. So here's our slope. Commit this to memory. If you know 2 points on a line, then you can measure its slope by using this formula. Now, what we want to do is be able to write the equation for a line, right? So I'm actually going to give you two different ways to do this. The first is usually called the slope-intercept form. Okay, and here's, I'll just give it to you because I'm sure you've seen it before. It's y equals mx plus b. So this is the equation of a line. It represents some physical line. And what are these things? Well, m is, as discussed, it's the slope. And b is the y-intercept. So how far above or below the x-axis you cut through the y-axis. So here's the standard slope-intercept form of a line. I'll say x is the variable, and once you specify what x is, then y is given. All right, so we'll just do an example because again, I'm sure you've seen this stuff before. I'm sure you've seen slope-intercept form for a line. So let's see. Let's find an equation for the line with y-intercept. Oops, actually, we'll make this x. With x-intercept 3 and y-intercept 5. And I underestimated how much space I was going to need here, so I guess I'll just do it above. But here's what we have. We want to find the equation for this line, and we're given some geometric information about it. We're told the x-intercept is 3, the y-intercept is 5. How about we draw this? Let's draw what's going on. So the x-intercept is 3. So right here at, say, the point 3, 0, I know it cuts through the x-axis. And it's got a y-intercept 5, so I know up here 5 units above the x-axis, right here at the point 0, 5, it cuts through the y-axis. And if I know 2 points on a line, then I know the whole line, right? A straight line passing through these 2 points must look like this. And if I can draw the line, then I should be able to find the slope of this line, right? Geometrically, I knew how to draw it, so I geometrically knew the slope. Mathematically, I should be able to get the slope, right? And what's the slope? Well, I already plotted these 2 points. I know 2 points on the line, so I can measure the slope of the line, right? It's the change in y over the change in x. So we'll take this as our second point. So we'll do the y value of this one, which is 0, minus the y value of this one. So 0 minus 5. All right, there's delta y over delta x, 3 minus 0. So minus 5/3. There's our slope, right? This is m. Great, I know the slope. What else do I need to write the equation of a line? Well, using the line-intercept form, right, y equals mx plus b, I just need the y-intercept. There it is, it's 5. So putting this all together, y equals mx plus b, the equation of this line is y equals m minus 5/3 x plus b, 5. And there's, I won't say the equation of the line, it's a nice form, it's a standard form, but it's an equation because I could rearrange this, I could subtract 5 from both sides and get a different equation for the exact same line, right? They'd be algebraically equivalent, but they are slightly different equations given in different forms. I highly recommend any of these types of questions, when you're given some information about a line, draw it. I find drawing really helps because once I drew this, I realized, oh, I actually know 2 points on the line, so I can get the slope pretty easily, and the y-intercept is given. So that's all I needed, m and b. We'll do one more. Find the slope of the line whose equation is the following: 8x plus 3y equals 6. So you might be tempted, okay, y equals mx plus b, m is the slope, and m is the coefficient of x, so you might say my slope is 8, but that's not quite right. And why not? Well, because it's only the slope when the equation is given in the form y equals mx plus b. And this is not in that form, right? It's not in the so-called slope-intercept form. So what I need to do is rearrange it and put it in slope-intercept form. How do I do that? Well, slope-intercept form is y equals something, so we'll solve for y. Subtract 8x from both sides, we've got 3y equals minus 8x plus 6. And isolating y, we just need to divide both sides by 3. Y is minus 8/3 x, divide this term by 3, plus 6 over 3, which is 2. So if I want the y-intercept, I have it. Y-intercept is 2, but that's not what the question is asking for. The question is asking for the slope. So the slope is, now that it's in the correct y-intercept or slope-intercept form, the slope is the coefficient of x. Slope is minus 8/3. Awesome. So the slope-intercept form might be everyone's favorite. It might be everyone's favorite sort of standard form of a line because you can look at it and just immediately read off, here's my slope and then here's the y-intercept. But there is another standard form in which lines are often given, and it has a big advantage over slope-intercept that I'll get to in a second. It is the point-slope form. My handwriting is not the best, but that was a very ugly M. So it's the point-slope form, and here's what it is. So here's a line, and what I know is I know the slope, and I know a point on my line, just with any old coordinates x1 and y1. Alright, so here's the equation of this line. Y minus y1 equals m times x minus x1. And this is an equation for this line, where, once again, m, I told you m when in the context of lines, almost universally represents the slope. So m is the slope here. X is the variable, just like before. Y is then this dependent variable that once you specify x, then y is known. But x1 and y1 are just the coordinates of that point, x1 and y1, right? This point right here that you know on the line. So it has sort of a big advantage over the slope-intercept form, in that slope-intercept form, to write down the slope-intercept form, you need to know two things about the line, right? You need to know the slope, m, and you need to know the y-intercept. What is the y-intercept? Well, the y-intercept is just a very special point on the line, right? It's a special point where the line cuts through the y-axis. Here, you need to know two pieces of data. Once again, you need to know the slope of the line, but instead of having to know this special point, which is the y-intercept, you can go with any point at all. Any point at all, as long as you know the coordinates of any point on the line, then you know an equation for the line. So this is the point slope form, and it has that big advantage. So once again, this is something you absolutely should memorize. We will, in fact, make more use of this in calculus, I think, later on down the road than the slope-intercept form. So here's our first example using this material. Let's say find an equation for the line passing through. Here's a pretty standard question, just you're given 2 points on the line. 1, 3, and 5, 8. Alright, so like I said, I really like to draw. I'm very geometrically minded. I like to have pictures of what's going on. So let's try to indicate where these points would be. Let's say 1 across and 3 up, maybe right here. We'll pretend that's the point 1, 3. And 5 across, maybe somewhere over here, and 8 up, we'll pretend that's the point 5, 8. Okay, so we've got a line passing through these 2 points. And I want to write down the equation of this line. You'll notice it's pretty tricky to figure out what this y-intercept is, right? I don't know the y-intercept, I just know these 2 points on the line. But what can I do? Well, if I want to use the point slope form, what do I need? I need to know the slope of the line, and I need to know a point on the line. Well, actually I already have 2 points on the line, so all I need, right, here's a point on the line. Choose any one you want. Let's go 1, 3 because those numbers are smaller. So here I have a point on the line. What else do I need? I need the slope. Okay, well let's try to find the slope. This is something we've done already. If I know 2 points on the line, I can always find the slope, right? The slope is change in y over change in x. So change in y, we'll go with the y coordinate of this one, 8 minus 3. Okay, the difference in the y coordinates over the difference in the x coordinates. And because I started with 8 here for y, I've got to start with the x coordinate of this point here. 5 minus 1 is, what's that? 5 over 4. Cool. I have 2 important pieces of data about this line now. I know a point on the line, I know the slope of the line. So finding an equation of the line, we will go straight to the point slope form. Technically from here, by the way, you can figure out what the y-axis or y-intercept is. If you know the slope, you can sort of backtrack here and figure out what the y-intercept is, but I don't need any of that now, right? I can just go straight to the point slope form, which says I'm going to do y minus y1 equals m times x minus x1. And I know all of these things. So we've got y minus y1, the y coordinate of this point we chose, which is 3, equals m, 5 over 4, the slope, times x minus the x coordinate of the point we chose, 1. And if it was me, I'd say this is totally fine, right? If you want to leave your answer in that form, it's totally fine. My math lab, though, they might specify give your answer in the form y equals something. So if you were to do that, just solve for y. So y equals, we'll add 3 to both sides, and we'll distribute this at the same time. So 5 over 4x minus 5 over 4, so distribute this, and then we're going to add 3 to both sides, plus 3. And because I'm running out of space, I'll do something I try not to do usually, which is I will erase this right here. Minus 5 fourths plus 3, that's minus 5 fourths plus 12 fourths is, I think, 7 fourths. There we go. So if my math lab specified the form it wants the answer in, that one's fine as well. You'll notice, by the way, this is now in the standard slope-intercept form. So there's the slope en, 5/3, but if you want the y-intercept, it's actually for 7/4. This point right here would be 0 and 7/4. Alright, so this one's very similar to the last one. Find an equation for the line through 2 and minus 2 and 2 and 6. So very similar to the last problem, right? You're given 2 points on the line, you're asked to find the equation, so the technique should be very similar. Let's just jump straight into it. Let's try to find the slope. All right, I already know a point on the line, any of those points will do. So we'll try to find the slope, and the slope is the change in y values. How about I start off with this one? So we'll go minus 2 minus the y value from this guy, 6, over the change in x values. So 2 minus 2. Well, what's that? That's minus 8 over 0? Well, that's not good. Right? We can't divide by 0. This doesn't make any sense. So what does that mean? Well, it means the slope is undefined. And what does that mean? Well, geometrically, if we were to graph this, the reason the slope is undefined is because this is a line that goes through 2 and minus 2, so maybe we'll call that point 2. So go down 2 units, there's 2 and minus 2, and 2 and 6, so 2 and up 6 units, 2 and 6. The line through these 2 points is a vertical line. And so that's why the slope was undefined, that's why we got this division by 0. It's a vertical line. So what's the equation of a vertical line? Well, a vertical line going through x equals 2 is the line x equals 2. So that's all there is to it, right? It's just it's realizing that actually this is a vertical line, so it's got a slightly different form, right? It's one of these special cases. All right, so last but not least, I'll just make a note, something about parallel lines. Alright, so what are parallel lines? Well, here's an example. I'm sure geometrically you know what parallel lines are. Here's a line, and here's another line that looks hand-drawn but roughly parallel. Right? Why are they parallel? Because they never intersect each other. They never cross over each other. And another way of saying that is parallel. The reason they never intersect each other is because they have the same slope. So this is in fact the definition of two parallel lines, is same slope. Right, so maybe I'd call this one like y equals 3x minus 2. Right? I'm just making up numbers here. But if that one's 3x minus 2, then you know sort of what the equation of this one has to be. If this guy has slope 3, then this one has to be 3. So this would be y equals 3x, let's say, plus 1. It's got a positive y-intercept. So this is the definition of parallel. Parallel means they have the same slope, the same m values. Perpendicular lines are lines that are really sort of the complete opposite. So here's one line. A perpendicular line is one that cuts through this line at a right angle, so at 90 degrees. So I'll try to draw 90 degrees here. That's not quite 90 degrees. Let's see. What about that? There we go. So there's a right angle, right? They intersect each other, and they do so at a 90-degree angle. And turns out if you're perpendicular, you can still make some sort of relationship about their relation between their slopes, right? And perpendicular means the following. So let's say this is L1. We'll say L1, if this has slope m, then what's the slope of L2? If they were parallel, it would also be m, but L2, the slope is what's usually sometimes said as the negative reciprocal. So it's minus 1 over m. Right, the reciprocal is 1 over m, and it's the negative reciprocal, minus 1 over m. So anytime you have perpendicular lines, this is the relationship between their slopes. Right? One is m, and one is the negative reciprocal of m. So we'll end this section with one example. We'll do a part A and part B though. Find an equation for the line passing through the point 3, 2, and we'll say A, it will be parallel to the line with equation 2x plus 3y equals 4. And part B we'll just do perpendicular to it. Okay, so we want to find an equation for a line. And this is the question you should always ask yourself: what do I need to know to find the equation of a line? I need two pieces of data. I need a point on the line. Great. We know it passes through 3, 2, so I already have half of the problem done. I have a point on the line, and I need the slope of the line. Well, in case A, if it's parallel to this line, then it has the same slope as this line. So this guy, let's try to find the slope of this. Once again, remember, this is not given in standard form. It's not given in standard slope-intercept form. But if I rearrange and solve for y, it will be. So let's solve for y. 3y equals minus 2x plus 4. So solving for y is minus 2/3 x divided by 3 plus 4/3. So for this line, our slope is minus 2/3. Right? So for A, our slope is the same as that line. So our slope is going to be minus 2/3. And we know a point already. Our point is 3, 2. That's all we need. Now we can go straight to the point slope form. Right, what's the point slope form? Y minus y1 equals m times x minus x1. So we'll plug in our values. We've got y minus 2 equals the slope minus 2/3 times x minus x1, 3. Then there is our answer. Can I fit this on here? I think I can. We'll do part B. Again, I'm asking sort of the same question. Now we just want a perpendicular line. The point stays the same, right? We're still going to use the point 3, 2. What about the slope, though? Well, the slope is the negative reciprocal, because it's perpendicular to this line. It's the negative reciprocal of this slope. So it's minus 1 over minus 2/3. And I'm just going to erase this because I need more space. But how do you divide by fractions? Well, again, you flip it and you multiply, right? So, you multiply by the reciprocal if you want to think of it like that. So it's minus 1 is the top times the reciprocal at the bottom, minus 3/2. Right, 2/3 flipped is 3/2. So that is positive minus minus positive 3/2. So the equation for this line is y minus y1 equals m times x minus x1. Again, I always sort of write out the standard form. as the first thing I do, just to really commit these formulas to memory. And we'll start plugging stuff in. We've got y minus y1, 2, equals our slope, 3/2, times x, minus 3. And there's the form I'll get my answers in. It's the standard, the slope-intercept form. Is that slope-intercept? No, it's point-slope. This is given in point-slope form. And if MyMathLab doesn't specify, then go with this answer. If it wants y equals, if it wants the slope-intercept form, then go with that. Just rearrange it and solve for y. Alright, so lines are fun, but this is sort of all there is to lines. You just need to know, if you want the equation of a line, what are you looking for? You're looking for two pieces of data. The slope of the line, always the slope, and a point on the line. If that point is a special point, if it's the y-intercept, great, but any point will do. And we will use lines all the time in calculus. So this will come up again and again. Thanks.